Right. So, first question. In my own words, how would I face that how would I describe the challenge NASA faces in ensuring the astronauts arrive on Mars with good health and maintain their fitness? Well, one of the main constraints about all of that is the price and how it would be moved from Earth to space. Another way is how would you keep the astronauts in proper shape without fatigue on muscles and bones? That would be very difficult, but there are certain solutions that we can do to properly remedy those. Your next question was, what are the common changes in the body when astronauts spend time in space? Well, astronauts' bodies will atrophy. Their muscles will atrophy. Their bones will kind of become more brittle, or as I wrote it down on this, your bones will atrophy, which doesn't sound as good. Your immune system will weaken because you won't be exposed to the elements, and you won't be able to have proper defense against things. Your body won't be exposed to bacterias on Earth, so after a long period of time of no exposure to bacterias, there's going to be some problems with your immune system. Another thing would probably be cardiovascular issues. Because the gravity is so different on a different planet, you'd probably have a harder time or an easier time breathing, but either way, you'd be getting less or more oxygen into your system that you really need. So it wouldn't really be good for you in the long run. Your next question was, what kind of exercise equipment do astronauts use in space? Well, they use this type of harness that straps them down onto a treadmill that they can use. It kind of pushes them down onto it while they run on it to simulate, running on a treadmill. But it's not as effective as a normal treadmill because of the near zero G's that you're in while in a space station, satellite, or even a ship, like a spaceship. There's another machine that would simulate lifting by pushing down on you, and you would have to push up against it, basically simulating lifting a weight or pull up against it, depending on which direction it is. One of your questions was, what difficulties do astronauts have when they return to Earth after a long extended length of time on space? Well, the process of coming back, your body will have weakened and their bones will be more brittle, as it said earlier. And due to all of this, that's not just the only thing that'll be a problem. In most cases, the mental state will also be a large issue. In interviews with many astronauts, it's shown that they forgot gravity even existed, and they'll drop things in thin air. It's a weird thing that is a little, I don't know how to properly describe it, but your body will become so used to zero G's that your muscle memory will just be adapted to dropping things in midair instead of setting them down. It's more of a mental thing than a physical thing, if anything. And on this one, you asked me to make a ship that would simulate gravity and centrifugal force. Well, I can just show you that. How do I switch?
I don't know.
Okay. I made a little ship kind of thing. It will spin that way, kind of like a football, and this will be the general shape to keep it aerodynamic and have support beams supporting the proper rings to connect to it. There'll be the main workers' quarters, where in the center there will be zero G's, or close to zero G's, because it's the center and there's nothing. It's kind of just spinning in place, Well, on here, you're going to be pushed outwards due to the centrifugal force that is being applied to all sides. These are little rocket jet engines with air pressure in them that will spin the ship. They're on each ring, and the main jet is on the back of the rocket that will take proper jet fuel. Okay, and the next part of everything. The weight on Mars and your weight on Earth will very much differ in the amount of newtons and force that's being put down on you. On Earth it would be more of the proper equation would be W equals 70 times 9.8 squared, which would equal 6,722.8. And that will be the amount of gravities or newtons being forced down onto you. But on Mars, it'll be much less because of the lower gravity and the lack of a proper ecosphere or even atmosphere. So it would be more. The equation would be more to W equals 70 times 3.7 squared. That would round up to 958.3.
3.7 squared? Why are you
Yeah, that's the gravitational pull on Mars. And you want to times it because it's your body weight. And your next question kind of confused me a bit, but then I figured it out. Given the force of gravity on Mars is less than Earth, do you consider it likely that astronauts will experience difficulties exploring and conducting experiments on the surface of Mars after spending 9 months in space? To sum it up, yes. Gravity on Mars is much weaker compared to Earth. And it's much weaker compared to Earth. And Mars, well, because of the low gravity, you'd have trouble walking around and maneuvering. So the astronauts generally, other than just figuring out a way to move around, they would have to properly exercise to make sure that the gravity doesn't, make their body used to low gravity and having a general atrophy in muscles, bones, and other types of tissues in the body. So, your next question, that was actually hard to find out, considering the design of spinning spacecrafts, the research in part 2. Choose 2 or more of these designs you think would be most practical for real life in the Mars mission. Well, I couldn't find the names, really, of the actual spaceships. They're more of just designs and blueprints, but I can say who made them. So SpaceX and NASA collaborated on one. I could not really find a proper one that was in the making, that was another design for an actual spaceship, other than this NASA and SpaceX one. Because they decided to collaborate for the Mars mission, with SpaceX having the proper funding and NASA having the proper engineers and research material. That would be more of a symbiotic relationship, I guess you could say. I can't think of the proper word right now. But I could not find any other spaceships that were similar to that were actually designed and properly, not fiction for movies and stuff. I just found one that was proper. And then the other thing, in preparing for the return journey to Earth, how might astronauts exercise while they are on the Martian surface? Well, the exercise on Mars will be much more rigorous than on Earth because of the low gravity. You'll have to work maybe 10 times as much to keep up your body's proper condition. You'd probably have to eat more you'd probably have to take more vitamin supplements and and more things to keep your body in check, you'd have to exercise much more often, which I just said a minute ago. And you would also have to make sure that your skin is properly taken care of, and have checkups every now and then, because due to Mars not having a ozone layer, the radiation from the sun is coming at you full force. So, and the spacesuits that we have aren't fully insulated, so you'll still be getting some of that radiation. You'll have to check up on that, make sure it's not damaging your body, your cells, or even your immune system. The astronauts' motivation to exercise may suffer if they have to repeat the same limited training, is what you said, given the regimen for many months on end. One way to notify and engage in sports and physical games. You told me to suggest a new form of things. I suggest muscle stimulators, like the small electrical shocks that go through the muscles to keep them working and not really give them time to rest, so that they can get used to being in less gravity, so their body can still accommodate for Earth when they get home. And I mean muscle stimulators as in the things that bodybuilders will put on their muscles to shock them and make them contract and retract. Those things, depending on where they're put, like on the forearm or on the legs, could keep and depending on the voltage going through you, could depend on the amount of muscles and energy that you are sustaining. But I'm not saying that would work constantly. It would more be akin to... You look disappointed.
No, I'm not.
It'd be more akin to, yes, you would have to do basically the same exercise a lot. But remember that on Mars, your exercise regimen is very limited, because it's not like we can bring an entire gym to space, because spaceships have to be certain weights to go to exit our atmosphere and stay in space. And I'm not sure you want to bring like a 200-pound weight into space with almost a ton of exercise equipment. I'm not sure you want to do that, because then that could inhibit the shuttle or the spaceship from exiting Earth's atmosphere.
Mm-hmm.
We could technically send out a pod full of that equipment into space and pick it up on the way there. But that would be more difficult, because we have to determine the time in space that it would be in the Earth's orbit. We cannot send them at the same time, for there could be a chance of them colliding. And that's basically my entire study project on the Mars mission.